Hello everyone, continuing from our previous video, in this video we will do some more examples using the chain rule of derivatives. First of all, just a little bit review. So in the previous video we learned that derivative of something raised to power n. So this something is the inside function and raised to power n. So outside function is the power function. So in that case we learned that derivative is equal to derivative of outside times derivative of inside. So derivative of outside means you first apply the power rule. So bring the power down and raise the power reduced by 1 times derivative of inside. So we learned that chain rule is d outside times d inside. So let's do a few examples using this rule. All right, so in this example, I'm just going to rewrite the function as 2x squared minus 7x raised to power half, and our goal is to find the derivative. And we notice that, so taking the derivative on both sides, we should take the derivative with respect to x of this function. And we notice that here the variable is x, but here we don't have simply x. We have another expression. So it means we need to apply the chain rule. So in order to apply the chain rule, we notice that inside function is 2x squared minus 7x, and outside function is the power of inside function. So power of inside functions. Outside function is our power function. So when we take the derivative, so we're going to do derivative of outside. So first we apply the power rule. So bring the power down, and that's something raised to power half minus 1, reduce the power by 1 times derivative of inside. So derivative of 2x squared minus 7x. And I'm just going to write our inside here. So we get half 2x squared minus 7x raised to power negative half and 4x minus 7. Or if you want, you can rewrite your final answer in terms of positive exponents only. So in this case, we have 4x minus 7 over 2 times square root of 2x squared minus 7x. So this is our required derivative in this case. Let's try one more example quickly. So again, in this one, we have y is equal to x cubed plus x raised to power 5 over 3. And so notice that here we don't simply have x, we have another expression in terms of x. So when we take the derivative, so we have some inside function and then we have the outside function, which is our power function. So derivative of outside, so outside is the power function. Bring the power down, and then that's something raised to power, reduce the power by 1. So x cubed plus x, and by chain rule check the derivative of inside. So derivative of inside means x cubed plus x. So derivative of x cubed is 3x squared and derivative of x is 1. So overall we get 5 over 3 x cubed plus x raised to power 2 over 3 times 3x squared plus 1. So we applied our chain rule. So derivative of outside times derivative of inside. So don't forget your derivative of inside. That's the most common mistake that students make. They always they tend to forget that they need to multiply with the derivative of inside. And especially you can make the analogy with this COVID-19 situation. So never underestimate the power of staying inside. So be safe, stay indoors. Next, we move to a more complicated problem. So in this one, again, we need to find the derivative of this function. And when we try this, first thing we notice is that this is a function of the form u times v. So it is product of two functions. So where u is equal to x raised to power 5 minus 2 cube, and v is equal to 3x cube plus x, the whole thing raised to power 6. And previously we have learned the product rule of derivatives. So product rule was, so if u and v are the functions of x, then derivative of u times v, remember, 1d2 plus 2d1. Product rule is so much fun. So u times derivative of v plus v times derivative of u. So in this case, we're going to apply our product rule. So derivative of y with respect to x would be 1 as it is, or u as it is. So x5 minus 2 cube. And then derivative of v, which is your second factor, plus v as it is, derivative of u, x5 minus 2 whole thing raised to power 3. So this is our u v dash plus v u dash, our product rule. All right, so let's do the simplification now. So dy over dx, so u as it is, and derivative of v. So remember, so this is of the form inside function, and then outside function is the power function. So what we do, first we apply the power rule. So bring the power down, something raised to power, so reduce the power by 1 times the derivative of inside, so that would be 6x squared plus, sorry, 3 times 3, 9x squared plus 1. Similarly, then we have 3x cubed plus x whole thing raised to power 6 times derivative of this. So something raised to power 3. So bring the power down, and that's something raised to power 2, and multiplied by the derivative of something. So that is 5x raised to power 4. So now we are done with our calculus part. So we are done with taking the derivative. So in order to make this a little bit more nicer, so we need to just clean some math, and we just need to do some rearrangement of the terms. So basically we just need to do some algebraic manipulation now. So we're going to start with taking some common factors out. So take out common factors. So in this case, we notice that, so x5 minus 2, so we have a square here, we have a cube here. So we can take our square term out. So x5 minus 2 square, and then we have 6 and 3 here. So 3 is a common factor out, and then 3x cubed plus x. So we have 5 here and we have 6 here. So we can take the 5 copies out. So inside, so for the first term, we are left with 2, and we are left with 1 of x5 minus 2 and 9x squared plus 1. Similarly, in the second term, we are left with a 5 and x4 and 1 copy of 3x cubed plus x. And now we can expand whatever is inside this square bracket and solve it. So expanding it, we get, so 2 times, so here we get x5 times 9x squared, 9x7, plus x raised to power 5 minus 18x squared and minus 2. And similarly, we get 15x raised to power 7 plus 5x raised to power 5. So now we're going to multiply each term by 2 inside the bracket. So we get 3x raised to power 5 minus 2 square, 3x cubed plus x raised to power 5, and we have 18x7 plus 15x7, so that will give us 33x7. And then we have 2x raised to power 5 plus 5x raised to power 5, so that is 7x raised to power 5. And then square term, we have negative 36x squared, and we have negative 4 as our constant term. So that was our um, like we just did some rearrangement, and this is our nice solution to this problem. So always remember, so you can have chain and product rule together, or you can have quotient and chain rule together, and so on. So be mindful and think about how you're going to take the derivative of a composite function. Let's do one more example. So in this one, so you will notice that you have so some expression u on the top and some expression v on the bottom. So you have u over v form. And if you remember, we learned that derivative of u over v is, remember, so this is your low, this is your high. Low d high, so low d high minus high d low over the square of what's below. So this is your quotient rule. So if we take the derivative in this case, so we will have, so square of v, so that is square of the denominator, so x square minus 3, so raised to power 4, and then square of that, so that would be raised to power 8, and then denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator. So x square minus 3 whole thing raised to power 4. So then we get, so x square minus 3 raised to power 4 as it is. And in order to take the derivative of this, we need to apply the chain rule. So something raised to power 6 means 6 times, that's something raised to power 5. And then by the chain rule, we need to take the derivative of inside. Similarly, for the second term again, so something raised to power 4, so 4, decrease the power by 1, and then by chain rule take the derivative of inside, and the whole thing divided by x square minus 3 raised to power 8. Now we are done with the calculus part, and now we're going to do some algebraic manipulation to tidy up the things here. So take the common factors out. So in this case, so we have 4, so it's 12 here and 8 here. So we have 4 as a common factor out, and also we have, so we have 4 copies of x square minus 3 here and 3 copies here. So we can take x square minus 3 cube out, and then 2x plus 1, so 5 and 6 copies, so we can take 5 copies out. So inside we are left with, so in the first term we need to make 12, so we are left with a 3, and we need to make x square minus 3 raised to power 4, so we left with 1 copy of x square minus 3. And then we have minus in between, and we need a 2x, and we need another copy of 2x plus 1, so that overall we have 6 copies. All right, so that is our common factor. So x square minus 8, 3 raised to power 8. So in the next step, we notice that, so we have 5 copies, or we have 3 copies of x square minus 3 here and 8 copies here. So we get rid of 3 copies, and we are left with 5 copies in the denominator. So x square minus 3 raised to power 5, and we have 4 2x plus 1 raised to power 5. And inside, if we expand it, so 3 times x square minus 3 times 3, so we get 3x square minus 9, and similarly we get negative 4x square, negative 2x. And we get 4 times 2x plus 1 raised to power 5. 3 minus 4, negative 1, so negative x square minus 2x minus 9. divided by x square minus 3 raised to power 5. So this is our required solution. So in this problem, what we did was we used the chain and quotient rule together. So there is another approach that you can use to solve the same problem. So instead of using chain and quotient rule together, you could have used chain and product rule together. So I'll show you how to do that. So you have this problem, the exact same problem that we just finished. So another approach would be you can rewrite this function as y is equal to 2x plus 1 raised to power 6 times x square minus 3 raised to power negative 4. And then you can see that we have u times v form, and we could have used the product rule instead of the quotient rule. So you can choose whichever form you prefer better, whichever rule works better for you. I hope you enjoyed this video. So thanks for watching this video, and please subscribe to watch any future videos of this channel. Thank you.